Ever wonder how AI creates videos that feel real? It's not just about pixels, it's about understanding time and space. Today, we're diving into a breakthrough called Lumos-1, a model that's redefining how AI generates videos by solving a tricky puzzle: how to track where every part of a video is in time and space. Let's start with the basics. When you watch a video, your brain automatically notices where things are: the cat on the left, when they happen to jump at frame 12, and how they move. But for AI, this is a challenge. Traditional models struggle to keep track of spatiotemporal information, how things are positioned in both time and space. That's where Rotary Position Embedding comes in. Think of ROP as a GPS system for AI. It assigns unique coordinates to each part of a video, telling the model where a frame is in time and where objects are positioned. But here's the catch: early versions of ROP weren't perfect. They'd overfocus on time, like obsessing over the clock, and neglect spatial details, like forgetting where the cat is sitting. This is where 3D ROP steps in. It's like upgrading your GPS to handle 3D maps. Instead of just tracking time, it also encodes height and width positions. But even 3D ROP had issues. For example, in one experiment, researchers noticed that the model's attention was skewed. Temporal information, time, hogged high-frequency channels, while spatial details like the cat's position got stuck in low-frequency channels, like trying to read a map with blurry text. So how did they fix this? Enter MMROP, a smarter, more balanced system. Imagine dividing a library's shelves. Instead of stacking all the time-related books in one section, MMROP spreads them out across the entire library. It allocates frequencies more evenly, giving equal brainpower to time, height, and width. This means the model can now track subtle movements, like a cat's tail flick, and maintain spatial clarity where the cat is sitting. Here's the magic: MMROP doesn't just shuffle data, it scales it. By adjusting the resolution of positional data, it ensures the model doesn't get confused by compressed video formats. Think of it as adjusting a microscope, zooming in on details without losing the big picture. Hey there! Ever wonder how AI can turn a simple sentence into a video that feels almost too real? Today, we're diving into Lumos-1, a groundbreaking model that's rewriting the rules of text-to-video creation. Let's break down how it works, why it's so special, and what it means for the future of AI. So Lumos-1 isn't just another AI tool. It's designed to understand complex descriptions and bring them to life. Imagine saying, "a golden retriever basking in sunlight," and watching the model generate a video where the dog's fur glows, the grass sways, and the light shifts naturally. This isn't random guessing. It's a careful, step-by-step process that aligns with your words. But how does it do this? Let's simplify it. Lumos-1 uses something called RDF inference. Think of it as a step-by-step recipe for building videos. It starts by analyzing your text prompt, then paints the scene frame by frame. Like a painter who sketches the layout first, adds colors and layers details, Lumos-1 ensures every frame matches the description. Here's where it gets really cool. Lumos-1 adapts to any screen ratio. Even though it was mostly trained on 7:4 videos, it handles square, landscape, or even vertical formats seamlessly. How? A unified codebook, like a universal language for visual elements. No matter the shape, the model understands how to arrange objects, lighting, and motion to create coherent scenes. Check out the examples: a close-up of a dog's face, a bustling street scene, or a surfer riding a wave. These aren't just random clips. They're videos that feel natural, with smooth transitions and realistic details. Whether it's a red bus driving through snow or a duckling pecking in sunlight, Lumos-1 turns words into stories. Of course, no model is perfect. Lumos-1 training data is smaller than some competitors, so it might struggle with super complex scenes. But the team is already working on scaling up data and improving vision language understanding, so future versions will only get smarter. And here's the big picture: models like Lumos-1 could revolutionize fields from entertainment to education. But with great power comes great responsibility. Researchers stress the need for safeguards to prevent misuse. So what's next? As AI evolves, tools